All right, we're going to isolate the x plus 1 radical. Should have taken the 2x. It's that child stuffed with candy. Everyone likes candy. 2. What are we going to raise both sides to? Second power. How many terms are you squaring on the left? Your other left. 1. What happens to the square and the square root? What happens to the square and the square root? They cancel. How many terms are you squaring on the right? 2. When you're squaring 2 terms, what do you have to do? Foil, if you would. Foil the right-hand side. All right. Check yourself. Did you get 49 minus 14 square root of 2x plus 2x? That's the correct answer. If you do not have that negative 14 square root of 2x, then what you did was you distributed your square through. You cannot distribute a square through because is this a product or a quotient? No. So do your first, outer, inner, last. If you need to, and there's nothing wrong with this, write them down next to each other and do your foiling process. Do we have radicals left over? Yes. So we have to do step 3. Step 3 says go back to step 1 and isolate a radical. So how do we get this guy all by itself? One more time, please. I would not do that yet. I would subtract 2x. What else? Subtract 49. Okay. Doing so I get negative x minus 48 equals negative 14 square root of 2x. So let's talk about that. To truly isolate that radical, we'd have to divide everything by negative 14. The bad thing about that is we would have fractions, and when we go to square, we'd have to FOIL on the left-hand side with fractions. So what I'm going to suggest is let's at least make our life a little bit easier. Notice all the coefficients are what? Negative. If we multiply both sides by negative 1, at least it makes it quasi-nicer. Quasi is a technical term. And I'm just going to suggest we keep the 14 where it is to avoid fractions. But if we square both sides now, on the left we get a ridiculously big number. Oops, mom bad. But on the right, not only do you have to square the radical, what else do you have to square? The 14, because it's a product to a power. So we could isolate the radicals by dividing everything by 14, which is totally fine. But if we did that, in the next step, we'd have to FOIL with fractions. And because these would not reduce. So I just suggest we keep the 14 where it is to avoid fractions for now. Right. So if you would, FOIL, square. I'll put this up here. So x plus 48 quantity squared means you're going to multiply x plus 48 by itself. So first gives you x squared. Outer and inner each give you 48x, which will combine. class gives you what you get. Equals. On the right-hand side, we have to square the 14 and the square root of 2x. What is 14 squared? Times, what is the square root of 2x squared? 2x. Because the square and the square root cancel. So this right here is x squared plus 96x plus 2304 equals, what is 196 times 2x? What do you get? 292. Yeah. 392? Should be 390. 392x. Okay, and now everyone free. Okay, so this is a quadratic equation. And our previous ones were linear equations. And for linear, you got variable on one side and number on the other. Well, for quadratics, for all we know, you get everything to one side and you try to factor it. Oh my gosh. So we're going to bring this 392x to the other side by subtraction. So that gives us x squared minus 296x plus 2304 equals 0. So now, this does factor, and here comes the fun part. Think of two numbers whose product is 2304, but whose sum is negative 296. Someone say 8 and 288. Good job, class. 8 and 288. So here's the moral of the story. This one won't be on the test, but I might give you one that does factor very nicely. This is ridiculous. Unintentionally ridiculous. So if you set the first factor equal to 0, what does that say about x? X equals the second factor? 288. Well, here's the deal. If you check it, 8's okay, but not 288. All right, that one was ridiculous. Let's do a more likely example. Let's do, let me add a page. Boop. We'll work on this one. Boop. So here's example, oops. Suppose we have the square root of x plus 1 plus the square root of x equals 3. Fancy. Let's go through all 4 steps, pretending like that other one did not happen. That didn't happen. Never happened. First thing we're going to do is we're going to isolate a radical. Let's bring this to the other side by what operation? Subtraction. That's step 1. Step 2, we're going to raise both sides to a power. What power? On the left, how many terms are we squaring? So what happens to the square and the square root? Good. On the right, how many terms are we squaring? So what do we have to do? Foil. If you would, please foil. What does first give you? 9. Outer. Inner gives you the same thing. Last. Plus x. Questions? Step 3, do we have more radicals? Yeah. Isolate again. What cancels from both sides? The x's. Notice we have an x on the left and an x on the right. Gone. If we brought this 9 over by subtraction, what do we have on the left? After the subtraction, negative 8 equals, and on the right, negative 6 square roots of x. Well, this one's very nice. Even though we will be working with a fraction, it's only one fraction. So let's deal with that one. Let's isolate completely by dividing both sides by negative 6 and liking it. What is negative 8 over negative 6? 4/3. Step 2, raise both sides to a power. What power? Squared. What is 4/3 squared? 16 over 9. What is the square root of x squared? X. There's no more radicals. Going to step 4, if x equals 16 over 9, what does x equal? 16 over 9, very good. If you had checked it, it works. If you lived here, you'd be home by now. That's a much more typical example of when you have a step 3. Not like that other one we don't talk about. This one here. That was terrible. Now, here is the deal. In this class, we do nicer versions of Part F, but in other classes, they get a little more exciting. So you're going to see a version of this in college algebra. But in that case, you do have to worry about absolute values and also pluses and minuses and yada, yada, yada. But the whole thing that you're doing in this chapter, or in this section, I should say, is in the process of raising both sides to a number, you're actually raising both sides to the reciprocal. Because when you have a power to a power, you multiply. So if you raise both sides to the reciprocal and you multiply, what does that new exponent become? 1. And we like things when an exponent is 1 because it is whatever it is. So even though there's a 1/2 there, after we isolate this term that has the 1/2, we're going to square both sides. Because raising it to the 2 power, we'll have 1/2 times the 2 makes a 1. So if there were a 1/3, we raise it both sides to the cube. Later on in college algebra, you're going to have fun things like 3/2 power. Well, then you'd raise both sides to the 2/3 because that's the reciprocal. But then there's other stuff you have to worry about, but that's college algebra. You don't have to worry about that for now. 1521. And the guy who teaches it, how do we isolate this 2x plus 1 to the 1/2 power? Add 3. And then what? Divided by 4. You're staying. Yep, that's a new word for today, staying. Your same steps, or staying, your choice, apply. So step 1, isolate. Step 2, power. What is 2x plus 1 to the 1/2 to the second? 2x plus 1, because these cancel. The power to power you multiply, and that gives you a 1 there. What is 11/4 squared? solve for x, we need a common denominator because we're going to subtract 1 now. 1 is 16 sixteenths. So what's 121 sixteenths minus 16 sixteenths? 105 sixteenths. And just like before, instead of saying dividing by 2, let's multiply by 1/2. What do you get for x? 105 times 1. 16 over times 2. 32. Boom shakalaka. Isolate, power, repeat as necessary, solve.